Hey guys, it's Mr. Like, and today I want to talk about fire. I'm going to show you some really cool chemical reactions today. I think you're really going to like them. But I want to start by saying it's very important to remember, don't try some of this stuff at home. Chemistry, although understanding physical and chemical changes is something that I think fifth graders can handle, really understanding how the chemical reactions work is something you're probably going to do in high school and in college. Never, ever, ever mix chemicals if you don't know exactly what's going to happen. There are chemicals at your house that probably, in your bathroom or under your sinks, that if they're mixed in the wrong ways, they could actually really hurt you. So I want you to be very careful when you deal with chemicals. When I deal with chemicals, I have lots of safety things involved. I always wear my safety glasses to protect my eyes. I always wear my lab coat or something to protect my clothes as another layer of protection between my skin and the chemical reaction. I also am very highly trained. I went to college for this. I took lots of chemistry classes where they taught me how to be safe and how to do these chemical reactions and to predict what's going to happen. So, it's going to be fun, but don't try this at home. Firefighters often talk about three things when they talk about fire. First off, they talk about fuel. Fuel, they say, is one of the legs or one of the sides of the fire pyramid. Whenever something burns, there has to be some kind of fuel that's burning it. This case with a match, it's the wood, the carbon in the wood that's allowing the match to burn. In the case of a lighter, there's a butane gas in here, which also burns. Another part of the triangle is oxygen. In order to have a fire, you have to have oxygen. So in the reaction, you're taking the fuel, you're adding oxygen from the air, and then you're turning that into brand new things. Okay? And in different fires, there's different things that are made. There could be some ash that's made, like in the match. There could be some smoke that comes off of other fires. A lot of times, carbon dioxide is also made in a fire. So, in order to put a fire out, you need to take away one of the legs of the triangle. If you take away the fuel, meaning the fire has burned through all of the fuel, the fire is going to go out. If you take away the oxygen, an example of this would be smothering a fire. What happens if you catch on fire? Do you know what you're supposed to do? You're supposed to stop, drop, and roll, right? Well, the idea behind stop, drop, and roll is that you get to the ground and you roll around trying to get the fire between you and the ground. That doesn't allow oxygen into the fire because you're smothering it. You're kind of putting a fire blanket is another good example of how that works. So one way to put out a fire is to smother the fire. You're taking away that part of the triangle that is oxygen because you need oxygen in order to have the chemical change. The third triangle of the fire is actually heat. You have to have heat in order to get a fire. In terms of the match, I have to actually create some heat through friction when I start the match against the little box here. That creates enough heat to start the fire. Once the fire started, it creates its own heat, and then it can continue to go. With the lighter, it's the same thing. I create a little spark in here, enough heat in there to actually get the fire burning. Then, it's just the heat that the fire creates keeps it burning. So you have to have heat. This is actually how most firefighters fight a fire. What they do is they spray water on your house or on the building or whatever it is that's on fire. And when they spray water in a wide area and they spray it way out like this. And the idea there is that they're trying to take away enough heat. And if they can take away enough heat from that fire, then the fire will go out. So the chemical change from fuel to ash can be stopped by taking away any of those legs of that triangle or any of those sides of that triangle. And that's how firefighters fight fires. I get a lot of questions about my intro. That song that goes on and you see me go through a bunch of different sciencey things. At the very end of that, I actually do an explosion. And I want to talk a little bit more about that explosion. So how I do that is I take some gas, and the gas that I use is actually called methane. Methane includes the atoms carbon and hydrogen. It's actually called CH4. Methane is a gas that comes out of the ground. We actually can mine some methane. It comes from decompositions of things. It's actually the same gas that comes out of you, actually. But we use it here in chemistry from our gas jets. I actually have a jet here that is attached to a big tank of methane, or natural gas, that I can use. So what I do is I open this thing up, okay? And over here, I've got a funnel. And in the funnel, I've got some bubbles. And so if I can create a bubble filled with that methane, it's just ready to go. But all we have to do is add heat. So if I add some heat, we get a really cool fire. Let's take a look and see how that happens again. We have methane, CH4. And what do we add to it? What's that other ingredient that all fires need? Well, they need oxygen. And where do you suppose the oxygen comes from? That's right. There's oxygen all around us in the room. So the methane gas interacts with the oxygen in the room, and it actually creates new things. It undergoes a chemical change to create new things. And actually what happens is that carbon from the methane hooks up with that oxygen. And what do you make when you have carbon and oxygen together? Do we know? CO2, right? CO2. Well, what's left over? Well, we have some more oxygen. There's plenty of oxygen in the air. And we have some hydrogen from that methane. So what happens if we take hydrogen and oxygen and mix them? What do we get? We get water. We get H2O. So actually what I did is I took the methane gas that was created in the decomposition of things, animals, millions of years ago, that gas from the ground, I combined it with oxygen, and I made CO2, carbon dioxide, the same stuff you breathe out, and water. Those are two completely different things than the methane and the oxygen. This looks really cool in the dark. Okay, for my next chemical reaction, I want to talk about how fast reactions happen. Because those reactions that you just saw really burned really well. The fuel kind of burned through, the match burned kind of slowly, even the exploding ball of methane kind of went kind of slowly and through. That's because that methane has to come in contact with oxygen. It has to find the oxygen in order for it to make this chemical change. I want to show you now another reaction. I'm going to use this white substance. Now, I'm not going to tell you what this is because this is a do not try this at home kind of a video. But I'm going to put some of that in this jar here. Now, or in this Folgers can. Now, this is actually somewhat related to grain bins that we have in Iowa. We have these giant bins where we store corn. And what can happen is a bird can get inside there or something, and it'll rustle up the corn. And a lot of that dust from the corn starts to fill up the grain bin. Now, any kind of a spark will ignite that grain bin. Dust, as you know, doesn't explode. But if it's in the air and moving around and there's a whole bunch of it, it could all light at the same time. And let's see what happens. I'm going to put a little bit of, I got a candle in here so I can get a little bit of a flame. So what I'm going to do is I'm actually blow in there through a hose, which is going to make all of that powdery stuff go into the air at the same time. And it'll allow that heat to spread very quickly. Let's see what happens. This is called the grain bin explosion. Grain bins, if they don't have proper ventilation in order to get rid of some of that dust, something can get in there, rile it up, and then the tops can just explode. Most grain bins nowadays do have ways that we can stop this, but it is a really cool reaction to show that when those two things get together, they react very quickly. So if all those little pieces of dust, or in my case white powder, are in the air at the same time, they can all react at the same time. Okay, you guys are in for a treat. It is getting close to Halloween, so one of the things we do in high school that you can look forward to when you get up here is we blow up some pumpkins. So what we're going to be doing is we have this thing called calcium carbide. You can't get this at home, so don't try this at home. And what we're going to do is we're going to put this in here. Calcium carbide actually reacts with water. Go ahead and start that up. And when it reacts with water, it actually makes a new substance. It makes something called acetylene gas. And acetylene gas happens to be quite explosive. Let's see what happens. Lights. Lights. Ready? Do it.
Yep.
Are you ready?
Yeah.
Bro. Wow, I could do this all day. I hope you had a good time learning about fire and explosions. Hopefully you can see that there's chemistry all around you. Whenever things change, we can say that it's either a physical change, meaning it hasn't changed its actual form, or a chemical change where you get brand new stuff because those atoms and molecules have rearranged themselves to make something brand new. Take a look through the worksheet and see if you can answer some of those questions, and I'll see you next time.